Hello. Hi, class. So I'm splitting up the preparatory lecture into two parts this week because the first thing we're going to talk about is reshaping data and dealing with duplicates and missing data. The data set that we're working with in animal fights is really clean. Everyone responded to it. There's no missing, no duplicates. But I also want to highlight that one of the neat things about Stata is it's really easy to run simulations and do random perturbations of your data, which sometimes can be helpful if you're trying to model a decision, do statistical inference, or generally just build out some other exercises to get prepared for working with data that's not necessarily as clean. So the first thing we're going to do, as usual, we're going to clear out our workspace and we're going to load our processed animal fights data set. And the other thing I'm going to do is I'm going to do something called setting a seed. Now, setting a seed is important when, say, you're using random numbers. In other words, when we want to generate data, but we want it to be able to reproduce it. So sometimes the way random number generators work is they use, say, the timestamp that you run the code to generate a set of numbers. And if you want your work to be reproducible, which generally we do, we can set something called a seed, which will say, generate this set of random numbers based on this history. So what we're going to do is we're going to generate a random number. We're calling it random. And what this is going to be generated from is something called a uniform distribution. That's going to be part of another lecture video I'm going to send you. And a uniform random number is just a number between 0 and 1. So if we type in random, we see that our mean is very close to 0.5. We have values very close to 0 and very close to 1. So that's good. And why am I generating this random number? Because I want to mess up my data a little bit. As I mentioned, we don't have any duplicates in our data. There is a command called duplicates report in Stata that is really nice. We'll let you know if there are any duplicates. And right now it's telling us we have exactly 1,224 observations. So let's change that. So let's look at this expand command. What that does is it will duplicate observations on specific conditions. Expand 2 will generate a duplicate observation for every observation in our data set. I don't want to do that. Instead, I only want to generate observations for a subset of our data. And that's what I'm using this random variable for. So I'm basically saying create one duplicate if the random number I drew for a given row was greater than 0.9, and create 2 duplicates if the random number I drew for that given row was less than 0.03. So let's go through and do all that. So what did our duplicates report say? Let's go with that first. Now we have duplicate observations, and that sounds about right. We've got a couple of cases where we have 2 copies, and a fewer cases where we have 3 copies. So that looks good. So now that we know we have duplicates, what we can do is we can tag them. And what that does is it creates a variable called dupe_IDs. And what we can do is tabulate that. And we can see we've got a bunch of data that has 0 duplicates, some that have 1, and some that have 2. Right. Now, how do you deal with duplicates? Well, typically you want to think, is this a genuine duplicate that I want to ignore? Or is this maybe that I'm not coding my data properly and that there might be multiple occurrences? I will tell you that particularly if you're working with transactional data, you really have to be careful about that. So for instance, if individuals are paying for things, it's both really important in the sense that if you need things to balance, you need to know, say, the final total of a data set of, say, expenses, that then really making decisions in those contexts can really matter. So I don't have general advice, but duplicates are one of the big problems that can trip people up. And how do you get rid of duplicates? Well, if they're duplicated on the entire row, we can just use this command called duplicates drop. And now if we do duplicates report, we see we've got exact copies of our 1,224 observations. So now what I'm going to do is I'm going to regenerate all my duplicates, and this time I'm going to introduce a little bit of missingness into our fight data. So specifically what I'm going to do is I'm going to loop through every fight. I'm going to pick a random number, and if it is a duplicate, I'm going to erase whatever value it holds. And the other thing I want to highlight is the spy sort command. So we've got something called dupe order. So this, you can reorder and resort your data. And sometimes for certain commands, that can be really fateful as a decision. What it does is it generates and changes the order of your data. So first what we do is we sort by record number. And then what it does is for each case where there is a duplicate data, it creates this variable dupe order. I think I need to regenerate this code. Okay, and you can see that we've got 1, 2 cases where we have, I did not have the browser in video. We've got cases where we have 1, 2, 3 multiple observations. And when we look at the actual win site data, we have we can see the underlying changes. Now let's go introduce our missingness and see what happens. And so we see that we've made a handful of changes to our data set. A number of observations are now set to missing. Let's just browse through real quick and see if we can see any of them in the wild. What I'm looking for is a period, which corresponds to a missing value. And we've got one here. And I think if we scroll around, we can see others as well. but missing values in data are a little bit weird in that they don't have a proper evaluation the same way a missing value would in Excel. It sort of assumes that it's an infinite number, which we'll talk about a little bit more in class, but I don't want to get into it here. But let's try and drop these duplicates now. What ends up happening? Well, we made changes to the underlying data. So now it's not clear what is actually a true duplicate, because as I mentioned before, all duplicates are specified on the row level. So how can we fix this? Well, there are a couple of ways. One, first, let's just take a look at the code book, see how much missingness we have. And the short answer is not a whole lot. I mean, like 10, 20, 30, not huge amounts, but this is, I'd say, very good in the sense that if you were running a survey and you had this level of complete responses, I would say you had fantastic luck. But let's just count how many missing values we actually have. And so we see that we've got a handful of cases where students or individuals only missed one of the observations, and a handful where they missed 3 or more. So how can we handle this? Well, in this case, we artificially induced this missingness, and we still have our duplicates. So what can we do then? Well, there's a command that I introduced in the solutions video called collapse. And what we can do is look at that documentation first. And what it does is it makes a data set of summary statistics. So I could compute the mean, and it will just take the mean of all of the data. I could do the standard deviation, but I also have this option called first non-missing. And because I know that my true data is still in my data set, I could try and just grab the first non-missing value for my wins. And that's exactly what I'm going to do. And here, one thing you should know about the collapse command is you cannot have your by variable and the other covariates that you're collapsing on in the same. So you need to be a little careful where you write your varlist. So in this case, because age was the second variable and the record number was the first, I can use this dash operator to just specify all variables from the beginning to the very end. And let's generate that. The other thing that I want to highlight is when you collapse your data set, a lot changes in that labels are replaced by an indication that was part of the collapse command. So if we go to our code book and look at, say, wins fight, we are now in a world of 0 and 1, as opposed to the label, I could beat this animal in a fight. And just to do the education variable as well, we lose those labels. That's one of those things that you also need to watch out for. So the collapse command is very handy, but it also gets rid of a lot of information, even if it doesn't get rid of any actual data. The other thing I wanted to show you is that we can generate our and check if we've actually filled in all of the data by record number. So I'm generating this again. We still preserved our original row miss variable. So let's do that. And we can see that we, in fact, no longer have any missing data post-collapse. And the last bit that I wanted to show you before we end was an example of reshaping data. So sometimes it's just easier to make certain types of plots with certain types of data. So let's go through, use our original data set. So let's say I wanted to create a plot of which animal had the highest fighting rate. So there are a couple of ways I could do this. And some of these things are a little bit easier than others. So one is I could just do graph bar of wins. And let's take a look at what that looks like. It's not terrible. With like 15 categories, reading the legend is feasible. If you have individuals who are a little bit colorblind or color insensitive, it's hard to tell, say, is this a goose versus is this a gorilla, particularly if these lines are close together or similar values. Here we have a little bit of intuition to help us, but it's not necessarily the easiest thing to read. And ideally, we'd like to have our labels be on a different axis. So one of the things we can do is make our data friendlier, because we've got those commands like by and over, which allows us to really understand and plot the data however we like. So ideally, we'd want to move the data from a wide format to a long format. And the way you do that is currently we want each observation to be the answers to every question on the survey. Instead, what I want to change each row to be is the answer to a single question on the survey for a single person. So in other words, I'm going to make my data set, instead of having 15 questions about winning fights in each row, it's going to be a single question about winning a single fight. But I'm going to keep track of what animal they're fighting in each row and who is responding. And the way I do that is all I do is I tell Stata which variables I want to move to long, and I need to assign a unique identifier, in this case, the record number, and tell it what the new animal it wants to fight is. I also use this option string because typically Stata is expecting a sequential number, but it can also be something else. So let's do that and look at our data. And actually, just to be crystal clear of what's going on, currently we have 1,224 observations on our data set. We're going to reshape, and let's look how many observations we have. So we've gone from 1,224 to 1,800 approximately. And we also shrunk the number of variables we had. So we previously had all of these wins fights variables, and now all we have is the underlying wins fight flag. So why is this useful? Well, there are a couple of things that are nice about it. Is one, you can almost think of how a computer uses memory as sort of the area of a square or a rectangle. And particularly if you have a lot of missing data, building a square can sometimes be more expensive than chopping up pieces and stacking them so they're shaped like a rectangle. So that is one of the reasons why you might want to be working with long data. It's also just easier to plot certain things, and that's what we're going to do right now. And so I want to see who's winning these animal fights. So we can do that by gender. And this is a really clean plot off the bat, that you can see what variables are. You can, I think it might be a little hard to tell where the difference is largest. Just with your eye, a goose and a medium dog look like it's a pretty similar delta, but you can investigate quite a bit. And again, one of the things I also want to highlight is you could flip the order, and depending on what you're trying to communicate, you might prefer one versus the other. Yeah, so with that, I think we're at a pretty good stopping point. The one thing that I'll highlight is that you can also reshape your data. And that once you've figured out the command to reshape it into one, reshaping it into the other format is trivial. You just need to tell it to go back to Y, and it will do that. And what happens when we try and reshape long? It also preserves that memory as well. So the one thing you need to watch out for if you need to reshape your data on multiple dimensions, that is something to be aware of as well. All right, thank you so much. Bye.